Hello COIL people, this is Fab. I am one of your teachers in this COIL project. The main objective of the project is to share with you how the people in the Central America region and specifically Honduras build houses. Our systems are mainly based on masonry structures and frame structures made out of reinforced concrete. So in this introductory video, I'm going to show you the house we are going to be using throughout this project to show you our construction techniques and constructive processes. This house is a real example because it's a house that has structurally designed by me, and I am currently doing the supervision of works of this house. And the main purpose of the video is to show you the complete anatomy of a house, and we will start by the footing. The footing system is responsible for transmit the loads to the ground, and specifically for this house the footing system consists in isolated footings. These paths are made out of reinforced concrete, and the loads that came from each column goes directly to the concrete pad, and the concrete pad, which is called the footing, transfer the loads to the surrounding soil. If we go a little bit up in the section cut, we can see the beams. These foundation beams have two structural functions. One of the functions of these foundation beams is to give a kind of stiffness to the system, and for stiffness I mean the amount of movement that a certain body has when the force are applied on it. You don't need to master the concept right now because we are studying this at a schematic level. And as you can see, the foundation beams connects this portion of the footings with the surrounded or neighboring footings. These foundation beams serves as a base or as a starting point for the construction of the walls. You can see that most, but not all of the foundation footings support walls. Our walls are made out of masonry blocks. Such masonry blocks can be from concrete, hollow block of concrete, and it can also be bricks of uh, clay. As we go up in height, we can start to see the development of the columns. The columns in this structural system have the function to receive the loads of the story deck and the walls of the second floor, and to transfer such loads directly to the footings, and also the footings transfer the loads to the soil. In this brown color here, you can see the original natural terrain, and as I mentioned in the module 1 related to earthworks, this particularly lot have a natural slope, and it was the natural way of the terrain. And before, or in order to build the house, we need to level the ground, and the ground leveling you can see here in this gray color. That's our construction platform, which is a flat platform where we have to build our house. As you can see here in detail, there is a difference in height from this platform to this platform. That height, that difference in height is due to the ambient, and because inside of the house needs to be a little bit high than the areas surrounding the house. And that's because when the rain comes, uh, you don't want the some of the water come from the rain that goes inside of the house. So usually the inside spaces, for example, like the kitchen or the living room or the reception or the kitchen and the laundry area and so on, needs to be a little bit higher than the rest level of the house. And that height is usually 10 centimeters here in Honduras. Okay, as we go up, we continue to see the development of the house. It's important to mention that it is not modeled in this beam right now, but just at this level, at the top level of the doors and the windows, we have an structural element. That structural element serves to provide a kind of uh, top beam to form closed frame for any one of the structures. That structure specifically will be covered in the wall sections or the wall modules or maybe in the frame models. And as we go up, we achieve the ceiling. The ceiling is not a structural component, but is shown here in this very basic beam model, just to show you the different parts or anatomies that a house normally have. This region of here is the stairs to go from the first floor to the second floor, and as we continue to go up, now we can see the beams. These beams have the functionality to transfer loads from the story deck to the columns, and that's the main objective of all of these reinforced concrete beams. So we go up, oh, we can see these secondary beams. These secondary beams are a kind of uh, it might resemble some purlins, but we call secondary beams because specifically for this structural system, for this story deck, it works in the same on the next uh, way. We have a flat surface made out of reinforced concrete, and that flat surface lies on these secondary beams, and the secondary beams by its way transfer the loads to the primary beams that are the reinforced concrete beams. These structural systems for the story deck is called a steel deck, and is a very recent structural system used in the later years here in Honduras. And as we will see in the module dedicated to story deck, we are going to analyze and see different types of story systems or concrete slabs that exist and can be used for buildings and houses. But this one is very common here in Honduras. And after or above the secondary beams, we can see the slab, the concrete slab, and then over the concrete slab we can start to see the columns. These columns, is important to mention, it comes or it's a continuation of the main columns that goes straight to the footings. And here we have the walls, the masonry walls of the second floor. We continue go up, go up, go up until we reach these intermediate beams here that I mentioned before. The name is specific for that intermediate beams that forms a closed frame in every door opening and every window opening are called cargadores or soleras in Spanish. And as you can see, for some openings we have these very slender reinforced concrete columns, which are called jambas. In Spanish, there's no specific translation into English for that one, uh, and that's because I called it the name in Spanish here in Honduras. In different countries, it receives a different name. And as we go up, you can see we reach the ceiling level at the second floor, and a couple of centimeters up we can start to see the beams, the main beams for the second floor and the secondary beams for the second floor. As this example is a real example, the roof of the second floor of the house is a concrete slab. It's the same concrete slab or same structural system as used for the story deck, but this slab on the second floor is because the owner wants an area to do some kind of barbecue or have this area for future use. But not all houses built here have a top slab like this. In a conventional house, that could be a conventional roof system that it's made out of steel purlins like this, and then the corrugated sheet metal for the roof. And that's basically the structural system for the house we are going to study in this COIL project. And as we go along in every module, you will see the real pictures of this project. So hope you enjoy it, guys, and see you in the next module. Bye bye.